Many drainage and sewer systems fail for one simple reason: because the pipe slope was wrong. When it's too flat, the water stagnates. At the same time, when it's too steep, the solids get left behind. Poor slope design always leads to blocked sewers, overflowing drains, and expensive repairs. In this video, I will show you a simple professional method to calculate the slope of a drainage or sewer pipe step by step. This is the same approach used by engineers when designing stormwater and sewer systems. By the end of this video, you will know how to calculate slope, how to express slope correctly, and also how to check if a pipe slope is acceptable. But first, let's understand what pipe slope really means and why it matters. So what is pipe slope? Pipe slope is simply the vertical drop divided by the horizontal distance. It describes how steep a pipe is, and this slope helps determine the flow velocity, the self-cleaning ability, and the system performance. So a drainage pipe must have enough slope so water flows naturally by gravity. Slope is vertical drop divided by horizontal distance. So for example, if a pipe drops 1 meter over 100 meters, the slope is the vertical drop, which is 1 meter, divided by the horizontal distance, which is 100 meters. So we get a slope of 0.01. And there are several ways to express slope. The slope can be written as ratio, like 1 in 100, meaning 1 meter drop in 100 meters. Sometimes it can also be written as a percentage, like a slope is 1%. Or sometimes can also be written as a decimal value, like the slope equals to 0.01 meter per meter. So engineers use all these three forms, so it's good for you to master all of them. So let's take an example to show you the step-by-step calculation of how you can come with the slope. So the first step you have to do when you're doing the calculation for the slope is to first determine the invert levels. So invert level means that at the bottom of the pipe. Let's take this for our example. So we have the upstream invert level at 101.2 meters, the downstream invert level at 100.4. So what you really have to do is to calculate the vertical drop. So the vertical drop is the first value at the upstream side, which is 101.2 meters, minus 100.4 meters, which is at the downstream side. This gives us a vertical drop of 0.8 meters. We have to know the length of our pipe. In this case, the length of the pipe is 80 meters. Therefore, our slope becomes the drop divided by the length, which is 0.8 divided by 80. This gives us a slope of 0.01. Now this 0.01 is in decimal point, which equals 1% slope, or a 1 in 1, or a 1 in 100 meter slope, or the slope is just 0.01 meter per meter. So every movement you make extend by 1 meter, the slope changes by 0.01 meter. The slope of 1% is usually suitable for small drainage pipes because water flows well and sediments are less likely to settle. Let me address for you the common mistakes that we face when coming out with a slope. The first mistake is using ground levels instead of invert levels. You are supposed to always use invert levels, not the ground levels. The second mistake is the use of wrong units. So when you're doing this, you should make sure that units are matching all points. So if they're in meters, the meters must match meters. Do not mix meters with millimeters or other units. The last mistake is use of too small slopes, because when the slopes is very, very small, it causes blockages and sedimentation. So there should be a good range of slope to be adopted. That is why in the practical application, we solve all these problems by first doing a topographic survey, whereby we survey the land to come out with the right profile. Then from there, we can do some analysis on the profile or on the surface, and then decide on the best double slope that we can adopt to minimize over excavation and also to ensure efficiency of the system. And there are some practical engineering tips that we normally adopt while designing for our slope, like typical minimum slopes for small pipes normally ranges from 0.5 to 2%. Then for storm drains, it ranges from 0.3% to 1%. But the most important thing is to make sure you always check design standards as your reference point to guide you on how best you can size the system. But we should know that our slope must ensure adequate velocity and self-cleaning flow. If you're interested in practical engineering methods like this, please don't forget to subscribe to this channel. I share real engineering workflows used in practical engineering projects.